Now we use 32, we just don't need to change. I don't need to change, but you know.
I noticed in the ROM modules file that there were a limited number of suggestions or a limited number of alternatives for the number of processors. Do the number of processors in the WQMPP modules have to match the number of processors that you're using in the... Yes. Okay, so I can't do 44.
You can, but you modify both.
Right, but there's nothing pre-prepared for 44.
Yeah.
Okay, and I don't know how to prepare, how to make up those numbers for 44, so I'm going to choose one of the
You get that,
ones
you get that.
you've got pre-prepared.
Yeah.
Okay.
Just one quick question. If you suppose you went from 32, you've gotten your numbers, wanted to go down to 16, would you double all the numbers that are set up? So that way, that would be simple. But if you try and go 20, then
yeah. But it's not exactly double because you have a kind of, because you the boundary between different CPU. It's not exactly approximately it is.
I looked at those numbers. It's not scalable.
Exactly.
Okay.
So here another issue, but this I don't know if we need to talk about this. It was a headache for me, and this program is very important. This basically does the combine all the CPU's result. But on the cloud, somehow there are limitations for memory. It just simply does not work. So I have to modify it.
Okay.
Yeah. But if you do it, you may not need to. But this is a problem. I think we don't need to talk the detail, but I modify this program. I think a lot. So, if I think in the package you got, I will send you. I just send you a default one. Oh yeah, the default one is this one. This is the initial one.
Which one is that?
This is the initial. You use this. I think if you have a good machine, you do not have a memory limitation. You just use this one. This one is just accommodated for the limitation of memory on the cloud that we have. So just tell you that, but you know.
Okay, but the INIL 96, if I have a 32 core or a 64 thread computer and it's got a ton of memory, I can use the post INL 196.
Yeah.
But is there somewhere I have to specify that I have a whole lot of memory? No. It's do it, I would not say automatically, but sometimes if you really get a limitation for memory, you just bump up. You just stop running and give you an error signal, that kind of segmentation fault. But you just can't run it. All right, so the post 32 is to get around those errors.
Yeah.
But the post INIL 96 doesn't worry about that stuff.
No.
And if it runs a little faster.
Yeah.
Is that the point?
Yeah.
But this is just the post processor. It's not the simulation.
No.
So we're not talking about a lot of time difference.
Yeah.
So we might as well just use the post 32, which we know works with more limited. And the amount of RAM that you have is 16 gigs?
Yeah.
16?
Yeah. 60, I think. 60 memory on the...
60?
Yeah.
60 gigs?
Yeah. 60, but you have a 36 thread. So as you share with that, I think everyone just do not get a lot.
So in order to run a 32 core machine, a 32 core version of this, you need 64 gigs of RAM. 64.
Yeah.
Right?
Yeah. Anyway, so now we just go back to the compilation. I think we are all set. So we just make a file, and I think this is pre-processing or post-processing. So now we have a kind of, let's see, so we have this one compiled as well. And what I'm thinking is that we just compile everything and go back to the source file. And this one, I think now we want to compile the single CPU, right? And we just delete this one. Just remove it. And then link it to the one we want to use. Kind of lazy stuff. That. So now you look at the module files. Now it's actually using the one single CPU. So we got. Then we go back to the and then we just make sorry. I did something wrong, but yeah. No, I want to make but no, yeah, that's my fault. Anyway, we just want to make this one, right? This one is basically using a single CPU, right?
All right. Yeah. So Richard, this means that every time you make a single parallel processing run, you have to remake.
No. You make one time, it's useful forever if you don't want to change anything. You don't need to recompile you need to redo the decomposition, but you don't need to do the compilation.
Now I understand.
Yeah. So this is just one time for.
Once you build the Fortran program, in order to make a run, you have to do the decomposition, run the model, and then do the combining. And that's why it's 3 steps. And now I understand.
Yeah. Okay. Gotcha. Okay. Good. Excellent.
Sorry.
No. That's why we are here and what we are doing. You don't need to worry about this because we did a mistake for the parallel computation. So I just want to recompile it basically. This one. So just make the parallel. This one, okay. So it's for what I think it's most of them are the same here.
And so now we have a 1 CPU version of it.
Yeah. Now for safety, I think for safety, this one usually that's what I do. I just run like this. Okay, we know that what we are using. I think I needed to most likely clear everything.
Okay. I understand.
Yeah, and now.
But you've got an error on. You got an error at the end of the make file.
Yeah, somewhere this is not really a big deal. This is some program that we use to modify the hydrodynamic, files, kind of things. I never worried about it.
Okay.
And obviously this one is wrong because this did not use the good things. For safety, we do that. This one, okay. We call it 32 because we specify use 32.
CPU.
Yeah, exactly. And this one.
Last time when you did the make, you just typed the make.
Yeah.
You didn't put anything.
Yeah, because it's
you got the config file.
You make and that's why I deleted this one because this make with 32 CPU configuration, it won't work because it's no one. That's why I deleted. Okay. Now we have everything. We have everything here. So now we can go to run the models, I think.
Okay.
This problem, I think we have to look at the time. Here there are 2 ways. I want to first show you use a single CPU to run it because maybe you want to run it in your PC, right? And the code is exactly the same. You don't need to worry a lot, in fact. This kind of, we did not organize the things as we did for the 30-box modules. Basically, we put everything here. Parameter value, input, output there. There might be a reason is that when decompose, you put input, output, probably you need to change your program to direct where it is.
Can you say that again?
Here is you do a LS, right? All the files are here. Yeah, parameter value, input, output, everything is there.
Right, so they're all in one directory.
Yeah, they're one directory. That's what I'm trying to say.
When you make a run, you have to be in the run directory.
Yeah, it's here. Yeah,
right.
Basically, it's here. So what we do first, I want to do something. This is basically the output of the simulation that I did before. Okay, we don't need them. We just remove them, delete it.
This would have been the equivalent of what you looked at, the 30-box, essentially to provide initial conditions of the cycle.
Yeah.
So you're getting rid of all of
Exactly.
Okay.
Exactly.
But you could leave them there, it would just be overwritten.
Yeah.
Right, okay.
Exactly.
Okay.
Yeah. So now basically this is all the input files.
Right.
And I want to show you something.
Again, sorry, you still have a couple of spin files, they're not dot spin. Do you
Yeah,
any of the spin files?
That's fine. This is not the result.
Okay.
Because when we do the simulation, we need to do 2 times.
Right. Okay.
Yeah, so that's fine.
So you have run and then you have...
Exactly. So that's the thing is here. I want to show you something that's interesting. This is a whole model. We just run it with the 30-box code. Try if it works or not.
Yeah.
You can be assured that, okay, you got the full models. So we just try one thing, right? And I think it's 30, right? 30 box is 4 CR, right? We have like this. I think it is, right? So this, let's do a run. Let's do a run if it works. When it's run, I think, okay. Look, I think you really, when you got your, for the 30-box model, it's the same as the, what I'm running. But it's just the domain is larger, so you don't need to worry too much. You just stop it.
But it'll take enormous amounts of time.
Yeah, I will tell you. So you can see that a lot of data spin come out. This shows that it works. It works. Yeah. And it's unlikely we can run it. It's the same way we can do another trial. Do another trial basically use the one we just compiled a moment ago. I think it's now. It's here. Work, right? This one we call it the one CPU. Okay. The responses are not the same because when Carl did the 30-box model, he trying to put out a lot of information when you are running, right? But this one kind of not.
All right, so this eliminates a lot of screen runs.
Yeah, and now
Right.
you may worry, it works or not, it works. But do not say anything, Just works quietly, okay?
So now we're trying to run the full model on a single CPU.
Excellent. You can do that. You can do that on your PC, Just show you it's doable.
You could take, what, a 2-week vacation?
Not that, good question. Probably yes. And I just did one trial with 1 year because we run 20 years. 1 year basically use 8 hours, 20 minutes only run it. It's not too bad.
For 32?
No, for 1.
Oh, it runs.
But only 1 year, only 1 year. That's why I think you can do it because you can launch the model, you go to sleep, next morning you got a result. I mean, it's not that bad. It's not that.
And I've forgotten everything I did.
Yeah. So I did one run with one single CPU, and I saved the result here in the save. I just want to show you how long it's taken. I think some file was formed immediately when you launch the run. I think this one is created not 19 hours, 7 hours and 9 minutes. The last one is 3 o'clock 30, So you do the difference, I think basically is 8 hours 21 minutes. So just show you the scale, the time you need to run it. Yeah. So just show you this, we today I think we don't need to run it because we won't get the result anyway. This 20 minutes.
And that's 8 hours on whatever CPU they have in the cloud.
Yeah, you get that. Excellent. And your CPU might be better, might be faster, or might be slower, depending on how old your computer is. So now, and yes, now we go to the parallel computation. It's here. And so I don't need to talk too much because this you call the PEP. This the decomposed files there. But we can use it. As I told you that we have to decompose each time you run it. Simply we just remove them, okay? We just remove them. Now they disappear.
The decomposed programs only run in Linux.
No, I think if you correctly configure out your PC or Windows machine, you can do the job. The only thing I worry is that you have to have all the compilation option installed in your PC. Yeah. But once you figure out that, I think it's an excellent idea. If you have a PC, I think the minimum now is 4 threads, right? You run, basically 2 hours, right? Because we use 8 hours to run 1 year, one single CPU. So if you want 2 hours or 3 hours, you get the job done. That's pretty good. But you have to figure out. I think John said the day before yesterday, and you can build your own cluster with several PC, even, But you have you need to have the ability and the scale to do that. I remember when I was in Massachusetts, we run FACOM, but we do not have a cluster. And a smart guy just did a cluster himself with a bunch of station CPU, PC, just combine together. Hey, run pretty well, So you have to have the skill to do it, but it's yeah.
Right, but you can also buy 16,
sure.
32-core machine.
Yeah, if you go with 64, this I think excellent. I mean, this pretty good computation power. All right.
Okay.
So check this. That's what I do usually. This older result, we don't want it, so we just remove them.